Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous video, I solved the past 9 questions related with exercise number 7.5 related with chapter number 7 Trigonometry relevant with the topic Prove the Trigonometric Identities. In today's video, I am going to solve further next 4 questions related with the same exercise number 7.5. Question number 10, 11, 12 and question number 13 inshallah I will solve in this video. So let's move toward question number 10. Prove the identity cos x minus cos x sin square x will be equal to cos cube x. So let's suppose I take this side, which is actually left hand side, LHS. So we are given with cos x minus cos x and sin square x. In cos x sin square x, cos x is common, so we will take out cos x common. So inside from over here we are left with just 1 and minus time up. If I take out cos x common, I left with sin square x. Now further we know the identity that sin square theta plus cos square theta is equal to 1. Replace theta in the whole equation with x, so it becomes sin square x plus cos square x is equal to 1. Over here we need 1 minus sin square x, so shift sin square x on the right hand side, so it becomes cos square x will be 1 minus sin square x. So putting the value of cos square x is equal to 1 minus sin square x over here, so it becomes cos x into 1 minus sin square x is cos square x, so cos square x. So over here the power of cos x is 1 and over here the power of cos x is 2. So in multiplication when the bases are same, so the power should be added. So the power over here is 1 and over here is 2. So it becomes 1 plus 2. So it becomes cos x whole cube. So we can write it just like cos cube x. So hence we prove that cos x minus cos x sin square x is equal to cos cube x. Now move to the next question, question number 11. Sin x divided by 1 plus cos x plus 1 plus cos x divided by sin x should be equal to 2 cosecant x. So let's suppose I take left hand side. On the left hand side we are given with sin x divided by 1 plus cos x and plus 1 plus cos x and divided by sin x, and I will derive 2 cosecant x from this whole expression. So let's suppose I rationalize this fraction. So the rationalization method will be sin x divided by 1 plus cos x. So in the numerator we have 1 plus cos x, so I will multiply the conjugate of 1 plus cos x and also divide with the same 1 minus cos x. So 1 minus cos x and divide with 1 minus cos x. And plus over here we have 1 plus cos x divided by sin x. So it when sin multiply with 1 minus cos x, it becomes sin x into 1 minus cos time of x. In the numerator we have formula a plus b into a minus b gives us a square minus b square. So a square gives us 1 and minus time of b is cos x, so its square will become cos square x. So it is the formula 1 minus cos square x. You know that it is equal to sin square x because you know that sin square x and plus cos square x, it gives us a value 1. So by shifting the cos on the right hand side, it becomes sin square x will be equal to 1 minus cos square x. So the value of 1 minus cos square x is equal to sin square x. Now after this we have plus sin and 1 plus cos of x and divided by sin x. So it becomes sin x into 1 minus cos x divided by 1 minus cos square x. It is equal to sin square x. Sin square x. So it can be written as sin x multiply sin x and plus 1 plus cos of x divided by sin x. 1 sin x cancels out with 1 sin x. We are left with 1 minus cos x divided by sin x and plus 1 plus cos of x and divided by sin x. Why I do the method like this, that rationalize the first fraction and apply the same logic. Over here I need the LCM same because over here the LCM 1 plus cos x and sin x. So the method was very difficult and the question will be very difficult. That's why for the easiness I apply this method. So over here the LCM is same, so it becomes sin x. So over here in the numerator we are left with 1 minus cos x and over here we are left with 1 plus cos of x. Cos x and cos x are the relative inverse of each other. They will cancel out with each other, and 1 plus 1 will give us 2. 2 divided by sine x, and you know that 1 over sine x is the reciprocal of cosecant x, so it becomes 2 times of cosecant x. So on the right hand side we have 2 cosecant x, hence we prove. Now on to the next question, question number 12. Sine x divided by 1 plus cos x should be equal to 1 minus cos x over sine x. This question is very easy. You can derive each side from the corresponding side. So let's suppose I take this side, left hand side, and the left hand side we are given with sine x divided by 1 plus cos x. On the right hand side we need 1 minus cos x in the numerator. How can we get 1 minus cos x on the right hand side? We will just apply the rationalization method, multiplying the conjugate of 1 plus cos x. Its conjugate is 1 minus cos x. So multiply and divide with 1 minus cos x. So in the numerator we are left with sine x into 1 minus cos of x and divided by, over here we have formula a plus b into a minus b, which is equal to a square minus b square. So our a is 1, so 1 square gives us 1, minus time of b is cos, so it becomes cos square x. So now again 1 minus cos square x from this formula, you know that sine square x plus cos square x is equal to 1. So we are left with 1 minus cos square x, so shift cos square x on the right hand side. So our sine square x value will be 1 minus cos square x. So put it over here, it becomes sine x into 1 minus cos x divided by 1 minus cos square x is sine square x, which can be written as sine x into sine x. 1 sine x is cancelled out with sine, 1 sine x, we are left with 1 minus cos x divided by sine x. Hence we proved 1 minus cos x divided by sine x. Now move toward question number 13, which is the last question of today's lecture. 1 over 1 plus cos a plus 1 over 1 minus cos a will be equal to 2 plus 2 cotangent square a. Now taking left hand side, which is 1 over 1 plus cos of a and plus 1 over 1 minus cos of a. Now again I will make the denominator same. So for making the denominator same, I will apply the rationalization method, either with this fraction, either with this fraction. So I will, let's suppose, multiply the rationalization on this fraction. So it is 1 over 1 plus cos of a. So the conjugate of 1 plus cos a is 1 minus cos of a divided by 1 minus cos of a. And over here we are left with 1 over 1 minus cos of a. So 1 plus cos a over 1 minus cos a, it will give us a value sine square a. It will give us a value sine square a, because formula a plus b into a minus b gives us a square and minus time of b square. So it gives us 1 minus cos square a, and it is equal to sine square a according to the first formula. So in the numerator we are left with 1 minus cos a, and the denominator by simplification it gives us sine square a. Sine square a. And over here if I apply the rationalization method, so it is 1 over 1 minus cos a. Let's suppose I multiply 1 plus cos a and divide with 1 plus cos of a. So over here the formula a square minus b square, which gives us 1 minus cos square a, and it is equal to sine square a in the denominator, sine square a in the denominator. And the numerator we are left with 1 plus cos of a. Now in the LCM, the LCM are same, which is sine square a. So it becomes sine square a. In the numerator we are left with 1 minus cos a, and over here we are left with 1 plus cos of a. Minus cos a cancels out with cos a, we are left with 1 plus 1. So 2 divided by sine square a. And you know that sine is the reciprocal of cosecant, so 1 over sine will be actually equal to 2 into cosecant. But over here we have square, so it becomes 2 cosecant square a. Now you know there's this identity, 1 plus, you replace theta with a, so it becomes 1 plus cotangent square a will be equal to cosecant square a. So the value of cosecant square is 1 plus cotangent, so put it over here, it becomes 1 plus cosecant square is 1 plus cotangent square a. So multiply 2 with both of them, it becomes 2 plus 2 cotangent square a. Hence we prove 2 plus 2 cotangent square a. So with this question I finish my lecture. Thank you for watching. Subscribe my channel and also hit the bell icon to receive the upcoming notification about trigonometry class 10 mathematics. Thank you.